So here's some basic definitions you need to know for thermochemistry. Thermochemistry is the study of transfers of energy as heat occurring during chemical and physical changes. Temperature is the average kinetic energy of the particles in a sample. Kinetic energy and temperature are corresponding to each other, so if kinetic energy increases, temperature will increase. Heat is the energy transfers between samples because of temperature difference. It moves spontaneously from matter with higher temperature to lower temperature. It's also measured in joules, so you'll say blah 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 joules. And then specific heat is the energy transferred during temperature change depending on the type of material, the mass of material, or the size of temperature change. So here's another example. It says calculate the specific heat in a 15.4 gram sample that absorbs 393 joules when heated from 0 degrees to 37.6 degrees Celsius. You're going to use Q equals MC delta T. So you're going to look for your Q, which is your 393 joules, then your mass, which is your 15.4 grams, and then your C is what you're looking for, which is the specific heat, then your delta T, which is the temperature final minus the temperature initial. So it gives you both of those. So 37.6 minus 0 is just 37.6. So you start to plug that into your equation, and that gives you 393 equals your 15.4 times your temperature, 37.6, and your C, since that's what you're looking for. So you're just going to solve that algebraically and divide both sides by 15.4 times your temperature, and then you just put that into your calculator, and you should get 0.6787 as your specific heat. So here's another example. A 40 gram sample of ethanol releases 2,952 joules as it heats from 50 degrees Celsius. Find the final temperature. So in this one, you're going to use your formula Q equals MC delta T. Okay, so your Q is your 2,952 joules. Your mass is going to be your 40 gram sample. Then your specific heat you have to go look up. It gives you ethanol. So you have to look up either in the book or on the internet what the specific heat for ethanol is, which I found that it was 246. So then you find your delta T, which is temperature final minus temperature initial. You're looking for your final, so that's your question mark. So you're going to plug it into the equation. You're going to have 2 joules equals 40. You're going to put that in parentheses because you're going to multiply by other things. Your specific heat, 246. And then your temperature final minus your initial. So So you're just going to solve this algebraically. You're going to do 2,952 divided by your 40 times your 246, and then that's going to leave you with your temperature final minus 50, which is your temperature initial. So once you get this answer, all you have to do is add 50 to both sides to cancel this out. And then you end up coming up with 50.3 degrees Celsius.
Okay, so this whole section is just Q equals Q, and the point of it is to find thermal equilibrium, which is just heat going back and forth from hot to cold until the temperature is the same. The equation is Q lost plus Q gained equals 0, but we use negative Q lost equals Q gained, which is basically the same thing. And remember, Q equals MC delta T, so it's basically just this equation. If Q is positive, then the temperature is increasing, and if Q is negative, then it's decreasing. I think that's pretty obvious. Okay, so here's an example. It says, what is the final temperature when a 50-gram block of aluminum at 75 degrees Celsius is put into 25 grams of water at 50 degrees Celsius? And then it gives us the specific heat of aluminum in water. And what I'm going to do is I'm just going to go ahead and work out the equation, write everything down, and I'm just going to skip forward and then walk y'all through it. Okay, so our answer is 57.5, and how I got that was at first I wrote out all of the mass and specific heat and the change in temperature for aluminum and water, and then I just wrote out the equation right here, and aluminum is negative because when you put 75 degrees Celsius of aluminum into 50 degrees Celsius, that 75 is going to go down, and the 50 is going to go up, so that's why aluminum is negative and water is positive. And so I just put all the numbers in right here for aluminum and then water, and then I just times that 50 by 0.9 to make it easier, and the 25 times 4.186, and then I distributed that 45 to x and the 45 to 75 and the 104.65 to x and to 50, and then so that's what we got. And then I had to add 45x to both sides, and then I had to add 5,232.5 to both sides, and then I got 8,607.5 equals 149.65x, and then you had to divide 149.65, and then your x equals 57.5, which is your final temperature, and that's in Celsius. And a way you can check that is just by plugging in 57.5 to x for both of them, like right here, and then you'll end up with the same answer, it's just one of them is negative. And here's another example. It says when 26 grams of a metal at 94 degrees Celsius is added to 54 grams of water at 24 degrees Celsius, the temperature of the water rises to 32.5 degrees Celsius. What is the specific heat of the metal? And I'm just going to do the same thing I did with the other example and just skip forward. Okay, so this number is what we ended up with, 1.201 joules per grams Celsius, and how I did that was I just did the same thing I did on the other example, wrote everything out, did the equation, plugged the numbers in. This one was a little easier because I didn't have to mess with the temperature or anything, like with temperature final minus temperature initial, I just had to find specific heat, so that's a lot simpler. And you end up with a negative number, but you can't have a negative specific heat, so you just have to go with positive.
Okay, I'm going to talk about endothermic and exothermic reactions. An endothermic reaction is any chemical reaction that absorbs heat, and that's a graph of an example. An endothermic reaction is the heat actually coming into the substance, I guess. So if you have ice and the heat goes in, it gets hotter and it turns into water. And then when the heat goes into water, it'll turn into steam. And you can see the red arrows is the direction the heat's moving. It's going in to the substance. An exothermic reaction is any chemical reaction that releases energy in the form of heat or light. It is the opposite of an endothermic reaction, and that's a graph to show. An exothermic reaction releases the heat. So a gas steam, it's releasing the heat and it'll get colder to turn into water. And then the water will release more heat and get colder to turn into ice. And then you can see the red arrows, the heat's moving out instead of in. An endothermic reaction will have a positive delta H, and an exothermic will have a negative. Like melting H2O, and when it starts as a solid, it'll go to a liquid, it'll have a positive 6.1 kilojoules. The boiling point, you can see it goes from a liquid to a gas, and then it'll also have a positive because it's releasing the heat. When you're condensing and you're making it colder, it'll be a negative, like doing a gas to a liquid or a liquid to a solid. Okay, in this physical example, we're going to mix vinegar with baking soda. And the initial temperature of the vinegar is 22 degrees. And then once we put the baking soda in, you can see the reaction happening and the temperature will start to drop. Since the temperature is dropping, the heat is leaving the substance, and so it's an endothermic reaction because the heat's not exiting. And now it's dropping to 17.8, and the final temperature is 17.32. Okay, in this lab you'll see magnesium reacting with oxygen, and the heat is let out in the form of light, and it's an exothermic reaction because the heat's being released.
Okay, so this section is going to be about enthalpy changes.
Okay, so the change in enthalpy of the reactants equals the sum of the change of enthalpy in the products minus the sum of the change in enthalpy of the reactants. The delta sign stands for change and the sigma sign stands for sum of. The change in enthalpy of pure elements will always be zero. Enthalpy shows the heat absorbed by a system during a physical or chemical change. Hess's law helps us to calculate the change in enthalpy. Hess's law allows for us to calculate the change in enthalpy in every reaction. A negative change in enthalpy will be an exothermic reaction, while a positive change in enthalpy will be an endothermic reaction. Whenever working out the change in enthalpy, you must pay attention to the coefficients. Okay, here's our first example. We have to find the enthalpy change for the reaction 3NO2 plus H2O yields 2 HNO3 plus NO. The enthalpy for HNO3 is negative 207.36. The enthalpy for NO is 90.25. The enthalpy for NO2 is 33.18. And the enthalpy for H2O is negative 285.83. First, we have to find the enthalpy change for the products. So you have to pay attention to the coefficients. So 2 times the enthalpy for HNO3 would be 2 times negative 207.36 plus the enthalpy for NO2, which is 90.5. From that, you're going to subtract the enthalpy of the reactants. So pay attention to the coefficients again, and it's 3 times 33.18 plus negative 285.83. So once you subtract the products from the reactants, you get negative 138.18. Okay, here's our second example. Find the enthalpy change for the reaction CaCO3 plus 2HCl yields CaCl2 plus H2O plus CO2. The enthalpy for CaCl is negative 877.1. The enthalpy for H2O is negative 285.83. The enthalpy for CO2 is negative 393.51. The enthalpy for CaCO3 is negative 1206.6. And the enthalpy for HCl is negative 167.16. So again, we're going to take find the sum of the enthalpy in the products. So you take negative 877.1 plus negative 285.83 plus negative 393.51, and from that you're going to subtract the sum of the enthalpy in your reactants and pay attention to the coefficients. So you're going to take negative 1206.6 plus 2 times negative 167.16 and subtract it from the products, and you get negative 15.2.